Hello everyone, how are you? Hope all you are doing good. I am Abhishek Kumar Chaudhary, Senior Lecturer Physics. Today we are going to discuss a very important chapter, Neet point of view, moment of inertia. That chapter, moment of inertia and rotational mechanics. This is very important chapter, we all know. Rotational mechanics is very heavy one. From rotational mechanics also, there is one topic on which Neet is asking frequent questions, that is moment of inertia. It is a one topic question also, and almost in rotational mechanics, in all of the topics, suppose you are calculating torque, there also you will have I into alpha, or you are using angular momentum, spin angular momentum, there also we will have I into omega. I is moment of inertia I am talking about. Suppose we are calculating rotational kinetic energy, there also we will write a half I omega square. What I am trying to say, this particular topic is isolated topic also for question point of view, and almost in all other topics of rotational mechanics, we will use this topic indirectly or directly. So you can say the soul of the pillar of the chapter rotational mechanics is this. Now the point is, why it is important, why we are studying moment of inertia, what is the significance in this chapter, why it is that important. Inertia you have to understand. Moment of inertia we are talking now. So why inertia? This is basically mass moment of inertia, this chapter. There could be other moment of inertia also, but in our syllabus it is mass moment of inertia. Mass moment of inertia, it comes in rotational mechanics. If it is that important, why we don't study this topic before rotation? Many chapters we have done, work energy power or laws of motion. So why in those chapters it is not being taught? Because now we are into rotational mechanics, and whenever some motion is taking place, some inertia is also there. Like there is some inertia, and inertia is trying to oppose the motion, or trying to oppose or actually opposes. Like you can say whatever mass was doing, if I say linear or translational motion, this is translational motion. Translational motion means, here we are talking about linear motion, projectile motion, circular motion, translational motion. In these kind of motion, if I want to change velocity, means I want to accelerate the system, what we are writing here is force by mass. So basically we can see that acceleration is directly caused by a quantity called force, but there is one more quantity which is inversely proportional to that, and that m is opposing A. Means you want to provide A, mass will oppose it. Heavier is the mass, more acceleration is required for a certain constant force. Means simple language, if we try to understand, acceleration is change in velocity divided by time taken, and that is equal to force by mass. So if you want to change the velocity, if you want to speed up, if you want to speed down, if you want to start something from rest, you have to provide force. But that force alone is not deciding how much velocity will change. Mass is also playing the role, but inversely. So this mass is called measurement of linear inertia. This is not directly inertia I am not saying, but heavier body will have more inertia in translational motion. Now same thing I want to do, suppose we have a very thin disk, right? But disk mass is 1 kg. Just imagine in your mind, there is a very thin disk and disk mass is 1 kg. Since I am saying it is very thin, obviously its area will be more, right? Means it is spreaded in larger area, some volume, so that mass is 1 kg but very thin, right? Now I am telling you, just imagine 1 kg with a paper weight or simple weight that we use in measuring something. One weight is 1 kg and one thin disc of 1 kg. Now we are rotating both of them. The same torque I am applying both of them. If I will applying same torque on both of them, they both will not rotate in the same way. Body will have higher moment of inertia, will stop sooner, or it will be very tough to, little rotation will be generated there. Body will have lesser moment of inertia, will rotate more. Means mass is the same, 1 kg, still both are not rotating in the same way. these discussions we are going to make how rotation is being caused, who is supporting, who is opposing. Supporting is torque, who is the counterpart of force, but today we will focus on the opposing factor, that is moment of inertia. To understand this, we will see one demonstration. This is a body, rigid body. Rigid body. We are not talking about particle system, point system now, as of now. This is a rigid body, right? And this rigid body is rotating about a certain point. This is a point. From this point, axis is going, let's say this axis is going, and this body is rotating with an angular acceleration alpha. This is not constant angular velocity, it is angular acceleration. Means slowly it started and it is speeding up. The omega is increasing gradually, right? So this body, rigid body, is in rotational motion. Now if I will ask you, put a point, just take a point, not the entire body, just take a small point on the body. This small point P is at a distance r from the axis. Means when I am rotating, just focus on this pen. I am a rotating body, but I want you to notice the pen only. So pen only is moving in circular motion. I am rotating. If I am rotating like this, the pen will only move in circular motion. So when a body rotates, when a rigid body rotates, every point on the body move in circular motion except from the point of rotation, right? So this P point, not the body, just point P, it will move in circular motion like this. Okay, P is moving in circular motion. Now since here alpha is given, angular acceleration is given, there will be a tangential force. That tangential force will be R into alpha tangential acceleration into mass. So tangential force is m into tangential acceleration, force equal to m into a. Since force is tangential, acceleration is also tangential, and tangential acceleration we know is at equal to r alpha. Obviously r is the perpendicular distance. Tangent and radius, they has to be at 90 degree with each other, so that is the 90 degree angle, right? There will be a centripetal force also here, Fc. But since centripetal force is acting towards the center, about which point? About C point. What is the torque of centripetal force? 0. Because we all know that torque is force into perpendicular distance, and this force and R, they are in the same line. Same line means they are parallel or anti-parallel also, you can say in some cases. Both cases torque will not be there, because for torque the distance has to be perpendicular to the force. We know this. Okay, but if I am asking you what is the torque of tangential force? What is the torque of tangential force? So it is very much evident from here that tangential force and R are at 90 degree. So according to torque formula, that will be force tangential into perpendicular distance. Focus and notice what I am saying, perpendicular distance. Here R is not any distance of force. If R will be any other distance, again I will take that component which is perpendicular to force. So basically we have to take force into perpendicular distance for calculating the torque of tangential force. So this torque is equal to Ft. What Ft we have written up? Here Ft, please notice it. It is m into r alpha, and one r is here, so r square alpha. That is m r square into alpha. And if I want to write, suppose we are writing alpha value, alpha. So we will write alpha equal to torque by mr square. What is alpha? Angular acceleration. What is linear acceleration? Linear acceleration is force by mass. So what role A was doing? No, A was acceleration. Acceleration was speeding up, speeding down, changing the velocity. Changing velocity is by acceleration. So changing angular velocity. Some body is rotating or not rotating. Some body is stationary. You want to rotate it. So you will change its angular velocity from 0 to non-zero. For that you will have to provide alpha. Some body is rotating already, you want to speed it up or you want to speed it down. In that case also you have to provide alpha. So alpha will be supported by torque, just in the same way acceleration was supported by force, but acceleration was opposed by m, inverse proportion, opposed by m. In the same way alpha is opposed by this quantity mr square, who is opposing rotational acceleration mr square, and that mr square, where r is the perpendicular distance, that quantity is called moment of inertia. So this moment of inertia, it is doing the same role as mass is doing to acceleration, it is doing to angular acceleration. So if you want to change inertia or you want to measure inertia for translational motion, linear motion, then you need to measure mass. Similarly, moment of inertia, that is a quantity mr square, that gives you an idea about what? It gives you an idea about how much rotational motion is being opposed. So if I want to write what? Definition of it. How the definition looks like? Okay. Moment of inertia is opposing or tends to oppose, resisting, opposing anything, any change in rotational motion, any change in rotational motion. If your rotational motion is uniform, if your rotational motion is not changing, then means there you are not into inertia. Inertia is for resisting it. Inertia will be there, but inertia is measured always for changing motion, right? So what we got the definition of moment of inertia? Definition of moment of inertia, it is opposing or tends to oppose any change in rotational motion. And what formula we got? If you have noticed the formula, we got it equal to m into r perpendicular square. Always keep in mind m into r perpendicular square. And from that we can take, if this is okay, let's summarize what we have discussed. We have discussed first point, why moment of inertia? Moment of inertia because if we want to study rotational motion, change in rotation, there is a quantity which opposes the change in rotation, that is called moment of inertia. It is doing the same, it is playing the same role as was played by whom? As was played by mass in the translational motion. Second, what is the formula? M into perpendicular distance, always focus on perpendicular distance, that cannot be any distance. If any other distance is given other than perpendicular, then find the component and then mr perpendicular square. That is the two things we have discussed. In this thing, if you have noticed one more thing, moment of inertia depends on mass, okay? Depends on mass, that is very much evident. The first quantity there is mass, right? So moment of inertia depends on mass. The second quantity, if you will see, it is depending on distribution of mass, okay, about distribution of mass about the axis of rotation. How the mass is being distributed, it is also very, very important. Okay, so for theory question, keep that in mind. Okay, moment of inertia, what factors are affecting it? One is obviously the mass, and the second is how the mass is being distributed. That's why when we're taking example of the disc and the paperweight, both had the same mass, but one is in disc form, one is paperweight form. So mass alone is not deciding moment of inertia. Distribution of mass about the axis of rotation. In the same body, if I will take different axis, one axis here, one axis here, one axis here, so distribution of mass about the axis is changing. That's why for the same body, we can have different moment of inertia. So it is not exclusively body's property. Body with axis of rotation. As many axis of rotation you are having in the body, as many nature of distribution of mass is there, and maybe that much moment of inertia you will get. That's why when you will do questions about diameter, about a parallel axis, perpendicular axis, these kind of questions we will do for the same body. So that's the definition of moment of inertia we have done. Okay. Okay, now the next one, just this slide, if you want to write something, you can write, and we will come to this moment of inertia of point mass system. Now, what is our knowledge from previous slide? Moment of inertia, mr square, rotational motion change, and it depends on mass and perpendicular distance square and distribution of mass. Okay, taking this forward, if I am taking this heading here, what system I have? What kind of system we are dealing with in this point mass system? So, what is point mass system? Point mass system means such masses which are in translational motion, because when a body moves in translational motion, any point of the body can give you idea about the motion, idea about the, like force, where you are applying force doesn't matter. Any point you will apply acceleration will be forced by mass. If it is a straight line motion or it is circular motion, for every point same trajectory will be there, locus will be same, different radius might be. So just keep one point in your mind. What is point mass system? As of now, point mass system I will take for those bodies which are in translational motion, means circular motion, projectile motion, linear motion, right? These kind of rigid body rotation, spinning rotation, right now we are not taking. For point mass system, moment of inertia I, that will be mr perpendicular square and all the summation I is equal to 1 to n. So moment of inertia of system will be mass number 1, its perpendicular distance from axis square, mass number 2, its perpendicular distance from axis square, mass number 3, again its perpendicular distance. That way we will keep going, and as many masses are there, you can see we are doing a scalar addition here. What we are doing? Scalar addition. Although it is a tensor quantity, but just mathematically when you will do addition, subtraction, you don't need to do here. Addition when you will do, what you will use here? You will simply use what addition? Scalar addition. So keep that in mind. For point mass system, for particle system, moment of inertia, as many masses, as many moment of inertia we will calculate, right? And in that we will keep track that every r that we are writing, r is perpendicular distance. I am insisting on this because sometimes that mistake we can do, we can just take the distance that is given in the question. That's why I am repeating it. It should be in your mind. You should not just follow the distance given in the question. You have to notice, you have to realize that that given distance is perpendicular distance on the axis. Okay, that is simple formula. So we will write like couple of questions on this, and while I am taking the question, just keep in mind as many masses, as many moment of inertia and perpendicular distance. So if that is okay, we will see few questions on it. Next question if I will take on this, that is this question. Okay, calculate moment of inertia of given particle system about axis AB. Before we will go on this, I want all of you to revise one formula for point mass. There are very routine questions coming on this. I am writing those formula. There is some mathematical formula that is useful. 1 plus 2 plus 3 sum of first n integers, that is n into n plus 1 by 2. Okay, keep that in mind. 1 square plus 2 square plus n square. Many questions we will use that. N plus 1, 2n plus 1 divided by 6. And the third one is the cube one. 1 cube plus 2 cube plus n cube. If I am going there, that will be just square of the first one. What is the first one? That is n into n plus 1 by 2 whole square. In moment of inertia, especially in point mass questions, we will have many questions on these three formula. So that formula should be a very routine and fixed formula for your revision. Okay, putting that in mind, if I am taking the next question, see that question everyone, put a thought to it. Calculate moment of inertia of given particles. So one thing is sure that we are using the point mass system, right? About axis AB, that is A, that is B. This is the axis AB. Okay, axis is also mentioned. Masses are point masses, so I am very much aware of my formula. I equal to summation all the mr square. As many masses, as many mr square, and we will add them up. So just do it. For first mass, if I will see mass number 1, mass number 1 is 1 and perpendicular distance. Focus the distance, everyone. If focus on distance, that distance 1 meter or 2 meter, every distance is at 90 degree, and that was the point we have to take perpendicular distance. Already the given distance is perpendicular. So 1 into 1 square plus second mass is 2. 2 into 2 square. Third mass is 3. 3 into 3 square and 4 into 4 square. Mathematically what we are getting here is 1 cube plus 2 cube plus 3 cube plus 4 cube. Okay. That is the cube of first 4 integer. We have just done in the previous slide. Okay, this cube formula is how much? Let's have a look. This we are going to use 1 cube, 2 cube, 3 cube, 4 cube. So n value, this n value in our question is 4. So I am putting this n into n is 4, n plus 1 is 5, n into n plus 1 by 2, and then what we will take? Square, and what square will be there? That will come 4 square 16, 5 square 25, and 2 square is 4. That will go 4, 25 into 4, 100. Unit we know, mr square will be kg meter square. Okay, so that's why I was saying that formula is very handy in most of the question, that first integer sum, first square of integer sum, that always keep in mind. That is very good formula to revise for particle system. One more very routine question that is frequent everywhere, you will see that question for particle system, especially when the axis passes through center of mass of two particle system. So we will take that question next. This is the question. Once read the question, we will see how to solve it. The question says that two particles, now it is two particles means point masses we are dealing with here, and formula is very much into our mind, m into r square, where r will be perpendicular distance. So two particles, what are the masses? 2 kg and 8 kg. They are tied at two ends of a massless rod. Rod is massless, there is no mass, there is no moment of inertia for the rod. So we will strictly think about these two masses, 2 kg and 8 kg, no rod moment of inertia. Rod length is given. Find moment of inertia of system about axis passing through center of mass and perpendicular to the line joining, that I was talking about. Sometimes question will come about center of mass axis of two particle system. For this question, I will suggest one very simple objective approach for you, then I will solve it properly also. See, objective approach, if I have one mass m1, right, and then another mass m2, and axis is passing through not center, rather center of mass, not passing through midpoint. Axis is passing through center of mass. Masses are different now, so center of mass will not be at the midpoint. So it is passing through center of mass. Whenever such question comes for angular momentum or for moment of inertia, what you need to do, you just take the axis as the same axis, center of mass, axis, whatever, wherever it is, distance r, that distance r is the separation between the masses. Whatever question gives you separation, distance r, that you take, and consider, please listen that very carefully, consider the two masses as one mass, two masses system as one mass system, and that one mass will be reduced mass, and reduced mass will be m1 m2 upon m1 plus m2, that is the one mass. So one mass, already r is at perpendicular, that is very much visible. So what will be moment of inertia if I have only one particle? Mr square, that m is mu r square. Answer will be m1 m2 upon m1 plus m2 into r square. So understand, again I am summarizing, the moment of inertia or anything is required for two particle system about their center of mass. So two particle system we will consider as one particle system. Out of two masses I will take one, and that one reduced mass will be m1 m2 upon m1 plus m2. If I will put all the values here, I will get the answer like m1 m2. See the data, 2 kg, 8 kg, 2 into 8, m1 plus m2, 2 plus 8, 10, r square, r is the total separation that is given as 20, 20 square, 8 into 2, 16, by 10, 20 square means 400. So this is 16 into 4, 640, okay, and unit we know kg meter square. So that way we can solve the question. This is the objective approach of two particle system where axis is passing through center of mass. If you want to know how this came, center of mass concept is working here. Center of mass concept means if I will say that 2 kg is at r1 distance and 8 kg is r2 distance. So from center of mass knowledge, what will be r1? R1 I am measuring from 2 kg. So that will be m2. M2 means this is m2 I am taking, that I am taking as m1. So r1 will be m2 upon m1 plus m2 into r. R is the total distance of 20 meter. R2 if you are writing, that will be m1 r upon m1 plus m2, right? And then moment of inertia, that will look like m1 into r1 square plus m2 into r2 square. We have the values of r1 and r2 like here. If we are putting this value here, r1 here, and this value r2 here, finally we are getting that only, m1 m2 upon m1 plus m2 into r square. That is the proper method of solving the question. You should know it, you must know it. But while you are doing the objective questions for them, then don't go, my suggestion, in that derivation. The NEET is very much examination according to the time constraint. It's not just knowledge in NEET. So always keep in mind, all short method you have to write and you have to revise well. If this question you are doing in NEET for 2-3 minutes, they are as good as not doing it, right? So whenever it comes, convert into one mass. You don't have to write it also, the diagram and all. Just you can imagine in your mind one mass is there, mu r square is the answer. So these are the two questions that are very important on moment of inertia particle system. Rest many questions are there obviously, but one where some integral sum like 1 to n, 1 square to n square, 1 cube to n cube, they are being used up in the question. And the second, two particle system where moment of inertia is required about the axis passing through center of mass, not center, not geometric center. Okay. So on particle system, briefly we have discussed it. To summarize in your mind, what you have done mr square, r is perpendicular distance, depends on mass and distribution of mass. Two types of question is a must revise. One is the integral summation all, and the second is where axis is passing through center of mass. Okay. After that, if you will revise, you will go on next step. Next step is this, moment of inertia for simple geometrical objects. Simple means I am talking about uniform distribution. Simple means, if I want to write what does simple indicate here, simple is indicating uniform distribution of mass. Uniform distribution of mass means, first of all, now your mass is not particle. Your mass is not particle, you have simple geometrical objects. You have object whose geometry is defined, like there is a length, there is a width, there is a sphere, there is a disk, means area is there, volume is there, geometrical objects are there, but their mass is distributed uniformly. There is no non-uniform distribution. If mass is distributed on length, for example, mass by length, which is also known as linear mass density. What we say? Linear mass density. Okay. Or if I say m by a, that will be what? Surface or superficial also. superficial or surface mass density, or mass is distributed on volume. We are talking about 3D bodies. Mass by A for laminar body, 2-dimensional body. Mass by length for 1D body. That will be volume mass distribution or cubical mass distribution. Volume mass density, right? So basically mass is distributed on dimensions. That is called linear density. Linear density. See, one thing I want all of you to notice. Density generally we say mass by volume, because every object has mass on volume practically. But when we are doing physics, we have 1D object. Practically there is no 1D object. There will be some volume. But when you see something wire, its length area is very small. So we can say that mostly mass is on length. So when you say density, mass by dimension, linear mass by length, surface mass by area, or cubical mass by volume. So density means mass upon what? Mass upon that dimension on which mass is distributed, right? Linear density means mass is distributed on length. Surface density, mass is distributed on area, and normally for every body it is cubical density. Mass is so density, mass density means mass upon that dimension on which mass is distributed. All of these three are constant. All of these three are constant. This is the condition of simple geometrical objects where these three densities will be constant. So we understood what is the meaning of the heading there. Now we will try to get how to get the moment of inertia. In these cases, the formula of moment of inertia would be integration of r square dm. Here we are using integration, your favorite, integration of r square dm. अच्छा, integration पे I want to tell all NEET students कि just basic integration like power n, x raised to power n, that will solve majority of question in NEET standard. So you don't actually have to enter into the depth of integration here, but get knowledge of the basic one, the power n1 algebraic integration, r square dm. That is the moment of inertia. And what is dm? When we write d, what is that? D is indicating differential, very small. What is d? D is very small. Dm is very small mass, very small mass. What is meaning of it? How can mass be very small? We are talking about geometrical objects. Just we discussed now. Mass is distributed on length, mass is distributed on area, mass is distributed on volume. And now I am talking about very small mass. It means it is very small length. See, if length is very small, its mass also will be very small. If area is very small, mass will be very small. So dm is very small mass, for very small dimension. In that dimension, what is coming? Very small dimensions. In this, what comes? In this, it comes length, very small area, very small volume. That you have to understand. Like suppose I am saying for dm is for linear body. So I will say mass, total mass upon total length into dl. If I am saying mass for superficial body where mass is distributed on area, laminar bodies, what I will say? Mass by area into small area. Or I am saying for 3D body, mass by volume into small volume. So this way we can write the value of small mass, small length mass, small area mass, small volume mass. And with no surprises, what is R? That is still the same, perpendicular distance. Okay, that is the basics behind moment of inertia of simple geometrical objects. If I will see some application of it, we can see this on, this is very important question model for moment of inertia. Very varieties are coming. On PYQs also you will see many questions on rod. So moment of inertia of uniform rod, no need to describe that rod is a simple geometrical object. Uniform word is already written. Uniform means mass is distributed uniformly and rod is one dimensional body as a consideration. So one dimensional body mass will be distributed on length. Okay, now see, suppose I am taking one very simple rod. This is a very simple rod. Its mass is m, length is l. Simple means uniformly distributed, and I want its rotational inertia, moment of inertia about center axis. Since it is uniform, center of mass is also at the center. It is rotating with some angular velocity or angular acceleration. Rotating, I want its moment of inertia. Omega is there, alpha is there, I want moment of inertia. So what kind of body is this? It is a uniform body. So I am sure first step in my mind, I have to use r square into dm. And then I know that dm is a very small mass. For very small mass, what we have to take a very small length. So I am taking this length from here at a very small, at a distance x, a very small length, dx we are considering. Now dx is a very small length, very small length. For total L length, what is the mass? M. For unit length, what is the mass? M by L. For dx length, for again C, for total length L, what is your mass? M. For unit length, what is your mass? M by L. For dx length, what is your mass? M by L dx. What is this? This is mass. This mass is of what length? Small length dx. Now dx is very small. So its mass also is very small. Okay. Now this is small mass, and this is small mass denotation is dm. So if I am putting this in place of dm, that is m by l into dx, and its perpendicular distance from axis is x. So r value is x here, and since center is there, so from center in the right hand side when I am measuring the rod, I am going only l by 2. Similarly, when I am going left hand side, also we are measuring L by 2. So minus minus means left side, and 2 there plus L by 2, that is the moment of inertia. Simple integration of this, x cube 2 plus 1 divided by 3 m by L, and limit is minus L by 2 to plus L by 2, that is m by L by 2 cube, L cube by 8 minus L by 2 cube, that will be minus L will be plus L cube by 8, and what we are getting from here, ml square by 12. Okay, that's a very simple formula. For Neet you have to memorize the formula ml square by 12. But this way, generally for rod, I will not suggest you to go in the question. You should know it. But there is a proper way that for rod question you should memorize. You can say trick, technique, anything, but that you should go with. So in simple trick form, it is very authentic trick, right? Not just for trick form I am saying this. So always this objective approach keep in mind. If uniform rod is there, uniform is a primary necessity here. Uniform rod is given and axis is passing through center. So you write m effective as m by 12 into total perpendicular length square, and perpendicular length is in this diagram L. If your axis is passing through end point, this is m effective into L perpendicular square. In this case, axis passing through end point, then write m effective as m by 3 and multiply by perpendicular length square, and you will get your moment of inertia. That is the objective approach where for uniform rod you can spare yourself from using integration. I am taking one example, but before that see it again. If axis is passing through center, you take m by 12 as effective mass, and axis is passing through end point, then you write m by 3 as effective mass, and effective mass is multiplied with that length which is perpendicular to axis, not the given length of the rod. For example, please have a look. Suppose one question comes, that is the axis, okay, and this is the rod, and this angle is theta. It is rotating like this. Length is L, mass is m. What is the moment of inertia? Obviously, we have to go with the proper method, small element, perpendicular distance. But suppose you are attempting an objective question, NEET level, then as I said, what I found here, my axis is passing through end point. As axis is passing through end point, effective mass I will take m by 3. So effective mass I have written m by 3. Okay, always for uniform rod. Okay, m by 3. Now I have to multiply this with what length? I have to multiply this with that length which is perpendicular to the axis. Again, disclaimer, not multiply with the original length of the rod. The length must be perpendicular to the axis. In that way, when I see perpendicular length, this angle is theta. If this angle is theta, vertical component will be cos. Along theta component will be cos, and that component will be L sin theta. So what is perpendicular to the axis? This is L cos, this is L sin. On axis, perpendicular length is coming L sin theta. So you will write here L sin theta square, and that is your moment of inertia without any integration. That I strongly suggest, recommend for objective approach. If at all it is coming for end point and center. Other point will come, obviously we will do with parallel axis theorem and all. But here, this point. If angle this theta would have been given, this angle would have been given as theta. Obviously it was L cos theta. If more than 2 rods also given, we can do that way only. Okay. We can see one more question on this, but that you understand the formula. This is just the basics how we have to use integration, but for objective approach, these two are very golden trick for rod questions. Apart from this, any other point is coming, we will use parallel axis theorem. I hope you understand. Okay. This one more question I am taking here. Try to understand the same technique we will use. Suppose my question is like this. Okay, that is the axis. Okay. And from here, one rod is like this in the plane, it is rotating. Means axis is perpendicular and rod is rotating that way. 2 rods are joined and they have been joined at, let's say, 90 degree. This mass is m. Okay. Length is L. This mass is m. Length is L. Okay. And it is rotating like this, and about O, I want to write moment of inertia. As I told you, use objective approach for uniform rod. I am assuming because no non-uniform distribution is given in the question. So we will take both rod as uniform. Now focus. How many total mass is there? It is m, m, 2m. But axis passing through end point. So I will write 2m total mass, but effective mass 2m by 3. Because axis passing through end point, that will be divided by 3. What is the perpendicular distance? This is 90 degree. I will not take this. I will not take this. What I strongly have to take that distance which is perpendicular to axis. If this is L, this is L, this is 90 degree. We all know it will be under root L square plus L square. That is root 2L. When I am squaring it here, I will get root 2L. Root 2L square. So I am multiplying the effective mass with the square of that length which is perpendicular to the axis. Actual length we are not taking, and we will get here 4 ml square by 3. That is the moment of inertia, which is saving us from using integration and sometimes the theorems also like parallel perpendicular. So this way you can make an approach on rod question especially to attempt objective questions. Okay, I hope this is more clear now. Now, if you will see the next one, one question we will solve on this. The question is this, AIPMT 2009 question. Okay, see this. 4 identical thin rods, each of mass m and length L, form a square frame, and we have to find moment of inertia about an axis through the center of the square and perpendicular to its plane. First of all, in this question, we have a square frame. A square frame means it is a rod question. It is not a square plate. A square plate is a different body altogether, right? So we have, please read the question again. Here a square frame is given. A square frame, rectangular frame, that is a rod question. Plate is a laminar body, different question altogether. So in this question there is a square frame. In this square frame all masses are M, thin rods, length is L. Now axis is also important. Moment of inertia of this frame about an axis passing through the center of the square. This is the point from where axis is passing. Okay. What is the moment of inertia? Now it all will rotate like this. Now consider one rod only. Just consider, try to focus on this rod AB. And this rod AB has a mass M, length L, and perpendicular distance from this is L by 2. This axis, dotted axis which is passing through center is also, if I will take from it, then it will rotate about this axis also and rotate about this. There is a C1 rotation and there is a C2 rotation. There are two types of rotation. Please understand again, this is not a point mass. This is not a point mass. This rotation is about C1, own axis, like own axis plus required axis, own axis rotation plus required axis rotation. That way we will have to think that question. Or you can say parallel axis theorem, but since we have not discussed that, I want you to get this approach. Okay, whenever a rigid body rotates and you want to find moment of inertia about any random axis, then you have to first see the moment of inertia about its self axis. Self axis, then required axis. Say self axis perpendicular to the plane. Before I will solve this question, suppose the same question is like this. I want about this axis, not perpendicular to the plane, rather in the plane. Then I will think that same axis on this rod, and about this rod, this will not rotate because rod is passing through length, there is no distribution of mass, then it will, self axis will be 0. So get that approach. If you want to write moment of inertia about any axis, write first similar self axis plus then write about the required axis. Self axis, required axis. If I will use that in this question, this AB self axis will be ml square by 12. ml square by 12 because it is passing through center. And then what is the distance? Parallel axis theorem, M. That distance L by 2, that will be L square by 4. We will discuss parallel axis theorem in detail. Just rod question is there, one AIPMT. So I wanted to share this approach with all of you. That approach here I am using. Okay. This way, how much it is coming? That is ML square by 3. That will be about this axis. ML square by 3. Every rod will be that way. This rod, first rod I have calculated. Second rod also will give you the same thing. Okay. ML square by 3. Third will also give you ML square by 3. Fourth will also give you ML square by 3. One more rod just we discuss. For this I am taking the approach self. About self ML square by 12 and about required that M into R square. So required, what is here? What is required for every rod? M into L by 2 square. About required axis, axis from where question is asking you. And self, the same axis, if it will be here, self for every rod is what? M L square by 12. Why? Because for every rod, the axis is passing through the center. So don't directly calculate about the required axis. Keep that solving technique in mind and solve questions using this. You will see every question that is applicable. Self required, self required. Wherever it is asking, first take that axis on the body itself. And how many such bodies are there? 4. So if you will add it, you will get 4 ml square by 3. So these kind of self and required technique, if you will attempt in many questions, I am showing you one more question here. See, suppose I am asking you, this is a rod, a square frame, ml, ml, ml. Focus on application of self plus required moment of inertia. And this is the axis about which this frame is rotating. I have 4 rods, 1 rod, 2 rod, 3 rod, 4 rod, and the axis is also in the plane. Okay. Now, if I am asking you what is moment of inertia of first rod? First rod axis is passing through the rod, there is no perpendicular distance of any point, there is no distribution of mass, entire rod is on the axis, there is no distribution of mass, hence moment of inertia I will write 0. For second body, this body, axis passes through end point, and end point I told you, effective mass is m by 3, perpendicular distance is L square. Simple, perpendicular distance is L, effective mass is m by 3. I3, no axis is passing through third, from third here to here, from no point axis is passing, right? Then I will use that. If axis not passing through the body, any point of the body, then self plus required. That you will in detail convert that into the parallel axis theorem, but I want you to know this approach for your objective questions. No point is such through which axis passes. So I will take this same axis on the body, self, I self. Always use I self plus I required in that case where axis is not passing through any point of the body. In previous question also, if I will take AB rod, this was the original axis, that was the axis. From any point of the body, axis was not passing, I used that approach. So you should write that in your notebook somewhere. If axis does not pass through any point of the body, we can take that axis similarly on the body, I self, then I required, and we will add them up. So for I3 students, what we will do? I3, if I will take this axis on I3, I will get 0. With the same logic, I1 was 0. This is self. What is the required? What is distance from it? L. So from required axis, it will be ml square. But if I will take that axis on the body, then it will be 0. I4 with the same technique of I2 will be ml square by 3. And if we will add all these 3, I1, all 4, sorry, I2 plus I3 plus I4, you will finally get ml square by 3, ml square by 3, 5 ml square by 3. Okay, so just make that note. Whenever axis does not pass through any point on the body, especially rod question we are talking about. Rod, no point axis is passing, axis somewhere else. I will take the axis same on the body, okay, nearest point on the body, and then about that point I will calculate moment of inertia, self, then the same body moment of inertia about that point required, and these two will be added. That is the moment of inertia of the rod. So I hope you got and enjoyed this session of moment of inertia. Solve all questions again, and in next session, whenever we will meet, we will discuss more about physics. Thank you very much. Keep rocking.